Hi everyone, my name is Amit Kumar Garg and welcome to my course of Getting Started with Apache Kafka. Let us quickly walk through the agenda of this course. This course will be divided into two parts. In the first part, we will cover about the introduction of the Apache Kafka, then installation of Apache Kafka on Windows machine and their basic commands, and then we will look into one producer and consumer Java applications. In the second video, we will cover about the important topic like Kafka topics, partitions, consumer groups, Kafka replications, Kafka offset, and some advanced configuration useful for the production environment. Okay, so what is Apache Kafka? So Apache Kafka is a messaging system based upon the publisher subscriber model. And if you will talk about what is a messaging system, so a messaging system is a system which is responsible for transferring data from one application to the another application. In any messaging system, there are a publisher and a subscriber. A publisher is an application who is sending the data, who is producing the data. And subscriber is an application or consumer is an application which is receiving the data. They both are receiving the data from a specific location. And in Apache Kafka, that location is called as a topic. So in Apache Kafka, we have a location that is called a topic. We have a public producer application, or we can call it as a publisher application as well. We have a consumer, or we can call it as a subscriber application. Then producer produce the message to this topic and consumer consume the message from this topic. In Apache Kafka, after consumption of the message is not going to delete it immediately. That is called message retention policy. And we will talk about this message retention policy in coming slides. And this topic reside inside into a machine, and that machine called as a broker. So you can think about a Linux machine where the Kafka is running, that is one broker, or we may have a window machine where the Kafka is running, that is also a one broker. And inside a broker, there might be a multiple topics. Producer application connects with the broker and consumer application also connect with the broker. And to achieve the high throughput and reliability distribution of the task, we have multiple brokers running and communicating with each other. This system is called as a Kafka cluster, and that is why Kafka is called as a distributed system. Okay, let us download the Kafka server. So to download the Kafka server, we will have to go onto the kafka.apache.org/downloads, and here you will find out all the releases from the Apache Kafka. So you can see that the current latest version is 3.5.1, and if you download the previous version, you can go down and you will find out the previous version as well. The second thing is that the binary is same for the Linux and Windows environment. So you can click on or you can download any of the binaries that will serve for both of the environments. So this is the link which you can use, and to save the time, I already have downloaded this on my Windows machine. So let us go there. We have downloaded and extracted the latest Kafka server into the C drive, and you can see that we have downloaded the 3.5.1, which is the latest version as of now today. If we go inside this Kafka server and go inside the bin directory, we will find a lot of .sh files, and these sh files are for the Linux machine. We have one Windows folder as well, and this window folder containing a lot of bat files. These bat files are for the window machine. We have downloaded the Kafka server and has been gone into the bin directory, seen some .sh file and .bat file. Now to start the Kafka server, we will first have to start the Zookeeper server. And Zookeeper server is a server which maintains the status of the Kafka cluster. We are not going to discuss about much onto the Zookeeper as the Kafka team is currently working upon to remove this one. So it might be possible that the later release of the Kafka, you might not able to seeing any Zookeeper there and you don't need to start this. And once the Zookeeper is started, we will have to start the Kafka server from this command. As we are on window machine, so I have been gone into the bin/windows directory, and if I will open the command prompt here, and type the zookeeper start command. So you will see that the zookeeper -server -start.bat file is there in this directory, and then providing the zookeeper properties. And if I will enter, zookeeper server is going to start in a minute. So you can see here that the zookeeper is started, and the zookeeper server is now running. Now to start the Kafka server, open another command prompt and type the kafka start.bat command. So here you can see kafka-server-start.bat and then providing the server properties. If I will hit enter, you will see that the Kafka server is going to be started in a minute. So you can see here that the Kafka server has been started. So now we can start creating the topic and start creating the producer and consumer application. We have already downloaded the software, gone to the bin directory and executed both of the command and started the Kafka server now. The next is there are some basic commands of the Kafka, so which you can execute from the command prompt. So this is the command to create a topic. So here we are creating a topic named Tacognite, where we are providing the bootstrap server, and bootstrap server is a server from where the system is going to get the basic configurations. As the Kafka is running on 9092, we have given the localhost 9092, and then we have given the replication factor and partition, which we are going to cover into the next video. Then there is another command to list all the Kafka topic exist in the current server. And then we have the describe topic commands as well. So we are going to look all of these commands in a minute on the command prompt. Next, we have a command to produce the message to any topic, and we have a command to consume the message from any topics. And there is another command to delete the topic as well. Let us go into the command prompt and see all these commands running. Let us now create a topic. And to create a topic, let us now open another command prompt. I have already copied the command and pasted here. You can see the command is kafka-topic.bat create topic and name of the topics. We are giving Tacognite as a name of the topic. Then the bootstrap server where we want to create this topic. So I want to create, or my Kafka server is running on my local machine. So I have given the localhost :9092. Then the replication factor is 1, as I am on the single Kafka node is running right now. Kafka broker is running right now. So I have given the replication factor as a 1, and then partition is 1. And we are going to cover both of the term into the next video. If I will hit enter, you will see that the Kafka topic is going to be created in a minute. So you can see that the Kafka topic has been created now. The next command we are going to see to list all the topic present in this Kafka cluster. So the command is kafka-topic.bat -list and then the bootstrap server from where we want to see all the topics present in this cluster. So you can see that right now there is only single topic, which is the Tacognite. The next command is describe command to describe any Kafka topics. So the command is same as previous, kafka-topic.bat -describe name of the topic and the bootstrap server. This command is going to give me the detail about this Tacognite topic. If I will hit enter, you will able to find out that the detail is the name of the topic is Tacognite. The topic ID is randomly generated by the system. Then there is only single partition and there is only single replica setup. The detail mentioned here we will discuss as we progress in this video. The next command is Kafka producer application. So you can create messages or you can push messages to any topic from the command line as well. And the command is kafka-console-producer.bat. Then name of any of the brokers. So you might be having the multiple broker running in a cluster. So you can provide any broker address. It is used to collect the metadata from this broker. You can pass multiple broker addresses as well if the particular broker is not available. And then the topic name. So we have provided the topic name as a Tacognite. And if I will hit enter, it will come up a little arrow. So This arrow means that I can start typing the message and it will publish this message to this topics. So if I will push message like a hello Techognite, so this one message has been gone to the server. So this one message has been gone to this Techognite topic, and any consumer listening on this topic is able to receive the message. I can pass any number of messages. So let me pass hello world. So now we have pushed the two messages. To exit, to come out, exit from this one, you can press Control C and it will ask you you want to terminate. You can press yes, and this will close our producer application. Now we have produced some messages. Let us consume that. And for the consumption, we have a command kafka-console-consumer hyphen bootstrap server hyphen topic and the name of the topic and hyphen from beginning. And this from beginning is to set the offset to 0. And if I will click enter, you can see both of the messages has been consumed and it is waiting for the next message to be consumed. Okay, so because we have only two messages and there is no producer, there is no new message is going to be coming now. If I will cancel this one and exit, and if I will execute the same command again, you will see that the both of the messages are going to be consumed again. And that is why we saying that the Kafka is not going to delete the messages as and when they are consumed, but there have some retention policy for the messages, which is by default 7 days. After 7 days by default, the Kafka is going to delete that one, and we can change that setting as well. Next command is to delete a Kafka topic. So this is the command kafka-topic.bat -delete, then the bootstrap server and name of the topic which we want to delete. If I will press enter, it will delete the Techognite topic. So in Kafka, the topics are not going to be deleted immediately, but they are marked for the deleted and will be deleted later in the time. Now, when we have produced and consumed some messages from the command line, let us write some Java code. And for the Java code, we are going to create a Maven project. For Kafka, we need Java 8 or later. For our demo, I am going to use the Java 11. Then for the Maven project, we need a single dependency, which is the Kafka client. And this is the latest version of the Kafka client, which is the 3.5.1. Let us first see the Kafka producer application. To connect with the Kafka using Java application, we first need to define the required properties. As we have seen this during the command line as well, the first property is bootstrap.server, and this is used to get the metadata of the cluster. It can be any address from the entire cluster. It might be possible that my cluster is having around 10 or 20 or multiple brokers. So we can pass the any of the broker address here, and this can having the multiple addresses as well. So I have given here two, but it might be three, four, five, any one of them. We generally pass multiple brokers. Kafka does not connect each of the broker to get the metadata, but it will connect the first one. If that is not available, it will connect to the second one and the third one continuously until it get the complete metadata and cluster information from the server. If we have passed only the single broker address here and that is not available, then our producer application will not work. The second and third property is key and value serializer. As you can see, we have defined string serializer for both key and value. The value of this serializer can be changed based upon the content of the message. If the value you are passing towards the broker is a blob, you can change the serializer according to that. Key and value serializer is used to optimize the size during the network transmission, and as well as during the storage, the Kafka broker use this value. Producer is the application who is responsible to provide how the message is going to be encoded, and the same value is going to be used during the consumptions as well. While using the command line, by default string serializer is used. That's why we haven't used to define while we are producing messages and consuming messages through the CMD. These three are the mandatory properties. There are other properties as well which you can set, but we will cover that as and when we progress through this video. So from this property object, we will create a Kafka producer object, and you can see we have passed as a string and string because our both key and value serializer are of string type. If value serializer of any another type, then we will have to change this value accordingly. So we will simply call new Kafka producer and pass the property object to create the Kafka producer object. Once the Kafka producer object has been created, the next is to create the producer record object. This producer record object required two mandatory property. One is the topic and second is the message itself. There are other variant of this producer record as well, which we will cover into the next video. The first property is the topic name on which we want to publish the message, and second property is the message itself. This message should be equivalent or matching to the serializer which we have passed in the value serializer. Once the producer record object has been created, we call the Kafka producer.send method to publish this message on the topic. Till now, we covered this part where our producer application is connecting to the Kafka broker and publishing a message towards the Tacognite topic, which is the message one. Let us now create a consumer application. So to create a consumer application, we will have to create a Kafka consumer object. This Kafka consumer object need the property object same as a producer. So we create a property object and pass the required properties. These four are the required property for a consumer. First is the bootstrap server, same as the producer. Key and value deserializer. The value of this key and value deserializer should be matching to the producer application. So if producer is producing messages into the string serializer, we will have to use the string deserializer here as well. Otherwise, the message will not be able to cast and we will get some error. Once we have defined the bootstrap and key and value serializer, the fourth property is the group ID. The group ID is used to define the consumer group. So within one group, the message will be delivered only once. Assuming that to achieve the high throughput, we have started multiple consumer. Now we want that these multiple consumers should process one message only once. So we define them into a group and the name of that group ID, name of that group we can define here as a group ID. If we will change the group ID name, let's assume that if this is a demo and we have given the another group as a test, then they both will receive a unique messages within that group. Now we have created a Kafka consumer object. Next is to subscribe some topics. So to subscribe the topics, we have created an array list object and pass the name of the topic and call the Kafka consumer.subscribe method. One single consumer can connect or can subscribe to many topics. So that means that the single consumer can receive messages from the multiple topic at once. So the second variant of the subscribe method is the regex option where we are saying that the any topic starting with demo hyphen is going to be subscribed. So let's assume that in Kafka broker there are two topics with the name of demo hyphen Kafka and demo hyphen Tocognite. Both are going to be subscribed using this syntax. The third thing is that if we will call the subscribe method multiple times, the last subscribe method will be in effect. Let's assume that we created the two array list, one with the array list mentioning the topic name as a Techognite, second array list mentioning the topic name as a test. And if we will call the Kafka consumer.subscribe with the test topics, so that means that we are going to subscribe only to the test topic, not the Techognite, because the test topic has been called at a last. So what we want to say here that the subscribe method is not incremental, but only the last subscribe method whatever we have called will be in fact impact. So again the second example, if we will call the kafka.subscribe topic and then we will call the kafka.subscribe topic hyphen star, then whichever has been called at last is going to be come into the picture. The other one or the previous one is going to be overwrite. Now we have subscribed to this Tacognite topic, but just subscribing to the topic will not start receiving messages towards the Kafka consumer. For that, we will have to call the poll function over the Kafka consumer object. This poll function returns the consumer records object, and we can iterate over this consumer records object using the for loop, and we will get the consumer record object from this for loop, and we will call the record dot value, which is the actual value which producer has sent us for the consumption. This for loop need one timeout, which is the in millisecond. So assuming that in the Tacognite topic we have some message already available to be processed by this consumer, then this poll function will immediately return us the records and we can consume that in our application. But assume that if all the messages has been consumed by this application, so the poll function will wait to receive the new messages, and the wait time will be the 1000 millisecond as per this configuration. We can change this wait time out as per our convenience and as per our application. Now, if after the wait, the topic has not received any of the new message, then this consumer record will return us the empty record set. Now, the poll is the function when the actual interaction towards the Kafka broker started. Till now, we just created the objects like the Kafka consumer object and the property object, but we haven't start the interaction towards the broker. So once we call the poll function, the actual interaction starts with the Kafka broker side. To continuously receive the messages from the topic, we will have to call the poll function again and again. So that is why we should always call our poll function inside a infinite loop. Second thing is that we should always call the poll function inside try, catch, and finally block, as the actual interaction towards the broker start at this stage only. And once we are done, we should always call kafka consumer.close to free up the resources. Now to unsubscribe topic from the Kafka consumer, we can call the unsubscribe method, which will unsubscribe from all the topics. Or the other way is that we can clear the topics or the clear the array list topics and call the subscribe function that will also unsubscribe from all the topic. If we want to partially unsubscribe the topic, then we can remove the topics which we want to unsubscribe and keep only those topics which we want to start consuming or keep consuming the messages and call the subscribe function again. Let us now create a Kafka producer and consumer application using Java code. To save the time and cover more things, we have already implemented the application. This is a simple Maven application. Uh, if you will look into the pom.xml file, we have added only one dependency, which is the Kafka client, and this 3.5.1 is a latest version. For our first demo, we created two classes. One is the consumer app and second is the producer app, and they all are into the com.tacognite.first package. If I will look into the consumer app, you will see that however, we already have been covered all of this property, but I will quickly walk through this one. We have written one main function. We have created a property file. We provided the bootstrap server. I'm on local machine and only one machine is working, which is the localhost 9092. However, I have given the 9093 as well when we have the multiple broker working, and if 9092 is not working, it will connect to 9093. Then we have provided the key deserializer and value deserializer. For this demo, we are going to produce messages into the string format and consume messages into the string format only. Then we have given our group ID. So if the multiple consumer are running for this topic, the Tacognite topic, and they all are into the same group, they will receive a message into a means they will receive a single message at once only within the group. From these properties, we created a Kafka consumer object. Then we created an array list and passed the topic name, which is the Tacognite, and then we will call the kafka.subscribe function. As we told you that the Kafka is a long running application and we always want to keep listening the topic and receive and consume the new messages. we have written this poll function inside a infinite loop. So we call the Kafka consumer.poll function, and we are passing the timeout in millisecond. So we can pass any timeout as per our application need. I have given 100 millisecond here. We can increase this one as well, and it will return us the consumer records object, and then we are iterating through this records object, and once we are done, we are finally closing this Kafka consumer. So let us run this one. So to run this one, I will go and call the run as Java application. If I will do that one, you will notice that a new consumer application has been started. You can see that the consumer app, and the application is not going to exit because we have written this application into the infinite loop. Now, if we will look into the producer application is almost similar. So we have written a main function. Here we have provided the mandatory properties. We have given the bootstrap server, same as the consumer. We have provided the key serializer and value serializer. Then we created the Kafka producer object using these properties, and we have given the topic name. Now to send the message, we will have to create a producer record object. We are creating a message, and we are simply appending the integer value, which is the 0 1 2 3 4, and we are producing 5 messages. Once we will call the Kafka producer.send function, the message is going to be delivered to this topic, and consumer will consume that message. So to start this one, again the same run as Java application will produce the 5 messages to this topic, and you can see that if I will keep it large, you can see that we have consumed that message as well, because the consumer is continuously running. If you will look into here, this is the consumer app, and we produce the 5 messages 0 1 2 3 4 5, and the consumer has read that one. If I will look into the producer logs, so I will move into the producer. Yeah, this is the producer terminal. You will see that it is mentioning that all message has been sent. Okay, now I have made a slight change in our producer application. You can see that I have added a infinite loop. I'm producing a message in every 500 millisecond. If I run this application, you will see that the consumer will start receiving the messages in a time. So you can see that in every 500 millisecond, a new message has been produced by the producer, and consumer is continuously receiving this one. And that is because we have written the consumer application inside a infinite loop, and that's why it is keep calling the poll function and receiving the messages continuously. That's it for this part 1 Kafka video. In the part 2, we will cover more topics like Kafka offset, Kafka replication, partition, messaging, advanced configuration, etc. etc. If you have any doubt, please write in the comment section. If you like the content, please subscribe to my channel. And at last, thanks for watching this video.